Boom, boom, boom. MIT astronomers detect a strange heartbeat billions of light years from our Earth. This is by Jennifer Chu, Massachusetts Institute of Technology on Science Tech Daily. Now, there are those that, especially from the Hebrew scholars, that tell us that the whole of the universe is palpitating at the rate of a heartbeat from one end of the universe to the other. Now, according to MIT, a distant neutron star could be the origin of a clear and periodic pattern of fast radio bursts, a strange and persistent radio signal from a far-off galaxy that appears to be flashing with surprising regularity has been detected by astronomers at MIT and elsewhere. The signal has been classified as a fast radio burst, or FRB for short, an intensely strong burst of radio waves of unknown astrophysical origin that typically last for a few milliseconds at most. However, this new signal is quite unique in that it persists for up to 3 seconds, about 1,000 times stronger than the average FRB. Without this window, the team of researchers detected bursts of radio waves that repeat every 0.2 seconds in a clear periodic pattern, similar to a beating heart. Labeled by astronomers as FRB 2019-1221A, the signal is currently the longest lasting FRB with the clearest periodic pattern ever detected to date. The source of the signal lies in a distant galaxy located several billion light years from Earth. Exactly what that source might be remains a mystery, though astrophysicists suspect that the signal could emanate from either a radio pulsar or a magnetar, both of which are types of neutron stars, extremely dense, rapidly spinning, collapsed cores of giant stars. There are not many things in the universe that emit strictly periodic signals, says Danielle Micheli, a postdoc at MIT Kavli Institute for Astrophysics and Space Research. Danielle says examples that we know of in our own galaxy are radio pulsars and magnetars, which rotate and produce a beaming emission similar to a lighthouse, and we think this new signal could be a magnetar or pulsar on steroids. Now, the team of scientists hopes to detect more periodic signals from this source, which could then be used as an astrophysical clock. For instance, they could use the frequency of the bursts and how they change as the source moves away from Earth to measure the rate at which the universe is expanding. The discovery is reported, it was a couple of days ago, 2 days ago, on July 13, 2022 in the journal Nature magazine, and is authored by members of the CHIME FRB collaboration, including MIT co-authors Calvin Leung, Juan Menapara, Caitlin Shin, and Kiyoshi Masui at MIT, along with Micheli, who led the discovery first as a researcher at McGill University in Montreal, Canada. After all, you know that I'm also Canadian. I used to live in Montreal. I used to go to the McGill Museum there. They even had shrunken heads there, but I won't go off on a tangent. Yes, and also researchers at McGill University, and then as postdoc at MIT. So, boom, 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 the first FRB discovered in 2007. Hundreds of similar radio flashes have been detected across the universe, most recently by the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, as interferometric radio telescope consisting of 4 large parabolic reflectors that's located at the Dominion Radio Astrophysical Observatory in British Columbia, Canada. CHIME continuously observes the skies as the Earth rotates and is designed to pick up radio waves emitted by hydrogen in the very earliest stages of the universe. The telescope also happens to be sensitive to fast radio bursts, and since it began observing the sky in 2018, CHIME has detected hundreds of FRBs emanating from different parts of the sky. The vast majority of FRBs observed to date are one-offs, ultra-bright bursts of radio waves that last for a few milliseconds before blinking off. Recently, researchers discovered the first periodic FRB that appeared to emit a regular pattern of radio waves. This signal consisted of 4-day window of random bursts that then repeated every 16 days. And this 16-day cycle indicated a periodic pattern of activity, though the signal of the actual radio burst was random rather than periodic. In December 21st, 2019, CHIME picked up a signal of a potential FRB, which immediately drew the attention of McKinley, who was scanning the incoming data. And he recalls it was unusual. Not only was it very long, lasting about 3 seconds, but there were periodic peaks that were remarkably precise, emitting every fraction of a second, boom, 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 like a heartbeat. This is the first time the signal itself is periodic, he said. Brilliant bursts. In analyzing the pattern of FRB 219-1221A's radio bursts, McChilly and his colleagues found similarities with emissions from radio pulsars and magnetars in our own galaxy. Radio pulsars are neutron stars that emit beams of radio waves appearing to pulse as a star rotates, while a similar emission is produced by magnetars due to their extreme magnetic fields. The main difference between the new signal and radio emissions from our own galactic pulsars and magnetars is that FRB 219-1221A appears to be more than 1 million times brighter. McChilly says that the luminous flashes may originate from a distant radio pulsar or magnetar that's normally less bright as it rotates, and for some unknown reason ejected a train of brilliant bursts in a rare 3-second window that CHIME was luckily positioned to catch. CHIME has now detected many FRBs with different properties, McChilly says. He says we've seen some that live inside clouds that are very turbulent, while others look like they're in clean environments. From the properties of this new signal, we can say that around this source, there's a cloud of plasma that must be extremely turbulent. The astronomers hope to catch additional bursts from the periodic FRB 219-1121A, which can help to refine their understanding of its source and of neutron stars in general. This detection raises the question of what could cause this extreme signal that we've never seen before, and how we can use this signal to study the universe, McChilly says. He says further telescopes promise to discover thousands of FRBs every month, and at that point we may find many more of these periodic signals. So this research was supported in part by the Canadian Foundation for Innovation, and it's by Jennifer Chu, Massachusetts Institute of Technology, on Science Tech Daily. I'll leave a link below for you for this. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.